Hi everyone, it's Miss H, and in this video we're going to be looking at acceleration. So what is acceleration? Acceleration is the change in velocity over time, or the rate at which velocity changes. Objects can accelerate by speeding up, slowing down, or changing direction. So you can think of this the same as if you hit the gas on your car, or the brakes on your car, or if you turn the steering wheel. The variable for acceleration is a lowercase a. The unit for acceleration is typically going to be meters per second squared or meters per second, but it can be any velocity unit divided by any time unit. So on the car, for example, you'll often hear, it goes 0 to 60 in 3 seconds. That would be miles per hour per second instead of miles per hour, or something like that. So it can be any velocity unit divided by any time unit. In this class, though, we're typically going to be sticking with meters per second squared or meters per second. The formula for acceleration is acceleration equals final velocity minus initial velocity over time. So if we put this into our helper triangle here, our VF minus VI goes in the top. We could have also used a delta V there to represent that. A and T go in the bottom. So if I want to solve for my A, I get my same formula back. If I want to solve for T, I have VF minus VI over A. And if I want to solve for initial or final velocity, I have VF minus VI equals AT. And then I just have to rearrange to get the VF or VI by itself. So let's take a look at some example problems. What is the deceleration of a car that was going 20 meters per second and came to a complete stop in 5 seconds? So first we're going to identify 20 meters per second says it was going that, so that's going to be my initial velocity. Complete stop tells me that my final velocity is 0 meters per second. My time is 5 seconds, and deceleration is just a different way of saying acceleration is just acceleration that's slowing down. So then my next step is to write my formula. A equals VF minus VI over T. Then I'm going to plug my numbers in. 0 meters per second minus 20 meters per second over 5 seconds. I'm just going to simplify this. You don't have to include this step, but it makes things a little easier to plug into the calculator this way. So then we have negative 20 meters per second divided by 5 seconds gives me an acceleration of negative 4 meters per second, or negative 4 meters per second squared. And then I'm just going to circle my answer to see that I'm done. All right, so that's our first example, solving for acceleration. Now let's look at another example. How long will it take to decelerate from 29 meters per second to 26 meters per second if the rate of deceleration is negative 2 meters per second So from tells me that my initial velocity is 29. 2 tells me that my final velocity is 26. The deceleration or acceleration is negative 2 meters per second. And how long means that I'm solving for time. So my formula is going to be T equals VF minus VI over A. So that's going to be 26 meters per second minus 29 meters per second over negative 2 meters per second. That's going to give me negative 3 meters per second over negative 2 meters per second. The meters per second cancel out, leaving me with just seconds. Negative 3 divided by negative 2 gives me 1.5 seconds. Okay, it's important to note that time can never be negative. So if you ended up with a negative time, most likely you flipped your initial and final velocities. It's also important to remember that negative acceleration doesn't necessarily mean that the object is slowing down. It could be speeding up but moving in a negative direction. So don't just automatically assume that a negative acceleration means that you're slowing down. But again, your time always has to be positive. So if it's final velocity minus initial velocity, then you're going to be slowing down if you have a negative acceleration, just in order to make sure that that time comes out positive. All right, let's take a look at another example. What will the final velocity be of someone who was sitting at a stoplight and accelerated at a rate of 3 meters per second for 10 seconds? So sitting at a stoplight tells us that our initial velocity was 0. The acceleration is 3, and the time is 10. It's asking us to solve for final velocity. So again, when I look at my triangle, I see that my formula is going to start out as VF minus VI equals A times T. So VF minus 0 equals 3 times 10. My seconds here are going to cancel out. So VF equals 30 meters per second. Now, if there had been a VI, if it hadn't been sitting at a stoplight, I would then have to add that initial velocity to that number in order to get the problem finished. So if the car had been traveling at 5 meters per second, then I would add that 5 meters per second to the 30 meters per second to get 35 meters per second. So if you have an initial velocity, once you solve for the A times T, you add the initial velocity to the other side to find the final velocity. All right, so let's take a look at one final example. What is the initial speed of a person who took 2 seconds to achieve a speed of 2.5 meters per second if he accelerated at a rate of 0.5 meters per second? So 2 seconds is my time. Achieve a speed tells me that my final velocity is 2.5 meters per second, and my acceleration is my 0.5 meters per second. I'm solving for initial velocity. So I'm going to start with that same formula, VF minus VI equals A times T. So that's going to give me 2.5 meters per second minus VI equals 0.5 meters per second times 2 seconds. My seconds are going to cancel out. So that leaves me with 2.5 meters per second minus VI equals 1 meter per second. I'm going to subtract the 2.5 to get it off of that one side. Okay, so that's going to leave me with negative VI equals negative 1.5 meters per second. Then I'm going to divide by negative 1 to get rid of the negative 1 in the front. So I have VI is 1.5 meters per second. And that's really the hardest thing you could be asked to solve for in an acceleration problem is the initial velocity, and just because it just takes that one extra step of dividing by the negative 1 at the end. Hopefully this gives you a good overview of what acceleration is.